This is the screencast for section 1.4, example 1. We're going to build functions from functions. The chart here from your book just demonstrates what these symbols mean. F plus g of x means you have two different functions, one called f, one called g, and you're adding them together. Same with the f minus g of x, f times g of x, f divided by g of x. It's just a sum, difference, product, and quotient. The bottom part here, it says that in each case, the domain of the new function, so the combined function, consists of all the numbers that belong to both the domain of f and the domain of g. So in other words, let's say 5 works in function f but doesn't work in function g. You can't use 5. It has to work in both functions. So we're going to look at some examples. Example 1 says f of x equals x squared and g of x equals the square root of x plus 1. Well, the easy part is adding, subtracting, multiplying, and dividing each of those. See? There they are. Here's the function f, x squared, plus the function g, square root of x plus 1. And then f minus g, f times g, f divided by g, and then the function g times itself. So let's talk about domains. First, I need to analyze the domain of f and g separately in order to find out which values are included in both of those functions. So let's see. F of x's domain, the domain of x squared is all real numbers. So far I have no restrictions on any of these functions that come from the function f. G of x, however, has restrictions. I can't take the square root of negatives, so the last number, the smallest number, I can plug in for x and take the square root successfully, is -1. So the domain of the g function includes -1 because I can plug in -1 for x, -1 plus 1 is 0, square root of 0 is 0. And then any number bigger than that will make the inside of my square root positive. So now I have restrictions. I can't use any of the numbers that f of x has in it less than -1 because g of x doesn't allow it. I have to be able to plug any x value into both of these functions now that I've combined them. So now if I'm going to work on the domain of the combined functions, I have to use the most restrictive of the domains. Any x value I use has to be able to get plugged into both the x squared and the square root of x plus 1 because now they've become one function. So the domain of f plus g is going to be including -1 to infinity. The domain of f minus g is also including 1 to positive infinity. The domain of f times g is also including -1 to infinity. Now the function f divided by g adds an extra restriction. The denominator cannot equal 0. So now all of a sudden -1 that used to be able to be plugged into the g function and all of these combined functions can no longer get plugged into f divided by g because that would make the denominator 0. So the domain of f over g is going to not include -1, but still will include all the numbers all the way up to positive infinity. Now this last one, g times g of x. Well, the question is, if you multiply a square root times a square root, don't you get just x plus 1? Isn't the domain all real numbers? Well, the domain of x plus 1 is all real numbers, but this function came from two other functions. So you cannot all of a sudden throw in all real numbers because the unsimplified version has restrictions on the domain -1 to infinity. So we've worked on these algebraically and thinking about them a little bit numerically. Graphically, your calculator will help you with these as well. Specifically, I want to look at this bottom function. You can try the other one separately on your own. But if you put in the f function to y1 and the g function into y2, then turn them off. So highlight their equal sign and hit enter so they won't graph anymore. Their equal signs should not be highlighted. Now in y3, you can tell it to multiply those two functions together. So I'm going to hit alpha F4 and go to y2, And I'm going to multiply alpha f4 y2 by itself. y2 has the g function in it, so now I'm telling y3, please graph g times itself. And let's see what that graph looks like. There it is. The domain is not all real numbers. It's -1, and let's make sure that includes -1. Yep, -1 has a y value that belongs with it. The now try problem for example 1 is number 3. F of x is the square root of x, and g of x is sine of x. So I can add, subtract, and multiply all three of those functions. And now I need to worry about what are the domain restrictions. The domain of the f function, square root of x, is including 0 to infinity. I can take the square root of 0 and anything higher. The domain of the sine function is all real numbers. I can't use all real numbers in these combined functions though, because negative numbers won't work for the square root portion of the combined functions. So the domain for each of these functions, so the domain of f plus g is going to be 0 to infinity. The domain of f minus g, also 0 to infinity. And the domain of f times g is also 0 to infinity. We don't have to worry about any further restrictions using division because this problem didn't ask us to divide, so we don't have to worry about the denominator being 0. We can also check any of these we want in our calculator. I put in f of x to y1, and I'm going to turn that off so it does not graph. Same thing with I put g of x in y2. We're using a trig function, so make sure you go to mode and you're in radian mode. Highlight radian and hit enter. Now I'm not going to check all of these, you can check them all on your own. But let's see, let me check and see what f plus g looks like. So the f function I put into y1, so I'm going to hit alpha f4 y1. And I'm going to add that to alpha f4 y2, the g function. And hopefully the domain will be 0, wait, down here. Yep, oh, up here, 0 to infinity. So if I hit trace, I have a y value that belongs with 0, but nothing anywhere to the left of 0.